Alright, so Jolene covered a glass of hot Milo with a lid as shown in the diagram below. A few minutes later, she observed some water droplets on the underside of the glass lid. Now we have done enough questions to know some facts for us to revise, to remember before we can answer this question. Right, we know that you know what condensation is. We know that condensation is when the vapor uses heat to a colder surface, okay, to become liquid water. Right, we know this is true. We know that water vapor is a gas, okay, and it needs to lose heat. So there are a lot of important things here. We know that water vapor is a gas. We know that it needs to lose heat. So the losing heat is very important, right? In order to become water, which is a liquid. We also know that evaporation occurs at various temperatures. What this means is that evaporation occurs all the time, but the more heat there is, okay, the more heat there is, the more evaporation, the faster the evaporation will be. The more heat there is, the faster the evaporation happens. Alright, okay, so let's look at the question. What should Jolene do if she wanted more water droplets to form on the underside of the glass lid in a shorter time? Okay, so we know that condensation is when water vapor loses heat to a colder surface. The greater the temperature difference, that means that the hotter the water vapor is and the colder the surface of the where the condensation occurs is, then the more water vapor will be formed. So what this is basically saying is that because this is hot, all right, there will be water vapor going upwards, right? There will be water vapor evaporating from there will be water evaporating into water vapor, right, going upwards and touching the colder surface of the glass lid. We know that it is a colder surface because the glass lid is at room temperature. Okay, the glass lid is at room temperature. Okay, because it's at room temperature, it is definitely much colder than the hot Milo. Alright, so and it's because this water vapor is losing heat. The water vapor is losing heat. That's why condensation occurs. Okay, the water vapor is losing heat to the colder glass lid. And that's why condensation happens. Alright, so how do we make the condensation even more? Well, that means we have to make the water vapor lose more heat. How do we make the water vapor lose more heat? Okay, in order for the water vapor to lose even more heat, right, this glass lid cannot be at this temperature, it must be even colder. Okay, so we need to find a way to make the glass lid colder than room temperature, right? So that the water vapor will lose more heat and therefore more water droplets will be formed. So what should Jolene do if she wanted more water droplets to form? Place some salt in the hot Milo. Place the setup in a sunny place. Place the sunny place, meaning that the surrounding temperature will be even warmer. Alright. Place some ice cubes on the glass lid. Or place the glass cup in a container of cold water. If you place the glass cup in a container of cold water, the hot Milo will not be that hot anymore. And let's say evaporation will take place. If you put ice cubes on the glass lid, it will actually make the glass lid colder. If you place the setup in a sunny place, the glass lid will be warmer. Okay. it will not affect the hot Milo. Maybe the hot Milo will lose its heat to the surrounding in a longer time, but the glass lid will be warmer than if it is in a room. Place some salt in the hot Milo. I do not know what salt does to hot Milo. Maybe just make it saltish. I do not know how it affects the heat inside the hot Milo. Okay, so with that, given you enough clues for you to answer this question, think about it and choose the appropriate option.